in this question, we're given a pattern. And we have to determine whether or not this pattern represents a linear relationship. And that relationship would be between the diagram number and the number of toothpicks used to make the diagrams. And to help us out, we're given a table of values here. On the left is the diagram number, on the right is the number of toothpicks used. So if I was to look at diagram number 1, you can see it's made up of 1, 2, 3, 4 toothpicks. So I'll put that number in there. And then of course for diagram 2 we could see that there would be 3 of these boxes, each with 4 toothpicks used to make them. So for diagram number 2 we'd have 4, 8, 12 toothpicks used. We can put that number here. And the pattern keeps going, so for each of these boxes we're using 4 toothpicks. So for diagram number 3 we're going to be using 4, 8, 12, 16, 20, 24 toothpicks. And we can put that number here. So now we have to figure out what would diagram number 4 look like. Well, if we see that at the bottom row, for each successive diagram we're increasing the number of boxes in the bottom row. So we'd have 4 in diagram number 4, like so. And if we look at the next row, we've got 0, 1, 2, so we'd increase by 1 each time. So on the second row we'd have 1, 2, 3 boxes. And then in the third row we'd have 2, and then we'd also create a fifth row for 1 box on the top. So if each of these boxes requires 4 toothpicks to make it, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of those boxes, each with 4 toothpicks. So the number of toothpicks required would be 4 times 10, or 40. So now that we have this relationship, we have to determine, is it linear? Well, one way to do it is to look at successive differences. So we can see between 1 and 2 it's going up by 1, between 2 and 3 it's going up by 1, between 3 and 4 it's going up by 1. That's consistent. Now if we look at the other side, between 4 and 12 we're going up by 8, between 12 and 24 we're going up by 12, and between 24 and 40 we're going up by 16. So the differences here are not the same, they're not consistent. Therefore we know that it is a non-linear relationship. But let's verify that. Let's use the grid here to also show that it's non-linear. On the horizontal axis we can put the diagram number 1, 2, 3, 4. And on the vertical axis, this could be the number of toothpicks used. So that would be maybe 2, 4, 6, 8, etc. And then we could plot the points. So for diagram number 1, there's 4 toothpicks used, so we can put that point right there. For diagram number 2, there's 12, so we can put that point right there. And for diagram number 3, there's 24, so we can put that point right there. And for diagram 4, there's 40, which would be up around here somewhere. And if we drew a smooth curve through these points, we'd see that it's nonlinear. Therefore, we know that the answer is correct. We verified it 2 different ways.